Welcome to Diamond Solutions for Mathematics. Today we are discussing differentiation of higher order derivative, that is x function and y functions are given. From that we have to find out d2y by dx squared second derivative. How we can do like that? Differential, we are stepping to differential equation, that is the last part of differentiation. Next, integration and differential calculus. If x equals a into cos t plus t sin t and y equals a into sin t minus t cos t, 0 less than t less than pi by 2, that is t is acute. Therefore, find d2x by dt squared, d2y by dt squared, and d2y by dx squared. Here, given x equals a cos t plus t sin t, and y equals a into sin t minus t cos t. First of all, we can take dx by dt. Dx by dt equals a into d by dt of cos t minus sin t plus t sin t means t into sin t product rule, t into d by dt of sin t cos t plus sin t into d by dt of t1 that I didn't written here. Therefore, minus sin t and plus sin t cancels. Therefore, here remains t cos t into a t cos t is the final result. Next, the second derivative of dx by dt, that is d2x by dt squared equals a into t cos t product rule, t into d by dt of cos t minus sin t plus cos t into d by dt of t1. That is a t sin, minus t sin t plus cos t, that is a into cos t minus t sin t. Next, dy by dt, that is y equals a into sin t minus t cos t. dy by dt equals a into d by dt of sin t cos t minus t cos t, t into cos t, that is product rule. That is d by dt of cos t minus sin t. Therefore, minus of minus is minus, next in minus t sin t plus d by dt of sin t cos t. That is a into cos t and minus cos t. This minus is taken inside as plus t sin t minus cos t. Minus cos t and plus cos t cancels. Therefore, a into minus of minus plus. Therefore, a t sin t is the final result of dy by dt. From this, we can find out the second derivative d2y by dt squared, that is a t sin t, is second derivative. A into t sin t, that is product rule. That is d2y by dt squared equals a into t sin t, that is product rule, t into d by dt of sin t cos t plus sin t into d by dt of t1. That is a into t cos t minus plus sin t. That is a into sin t plus t cos t is d2y by dt squared. dy by dt is defined as a t cos t. dx by dt is. Therefore, dy by dt is defined as a t sin t. From this, dy by dx is dy by dt into dt by dx. That is dy by dx equals dy by dt into divided by dx by dt. That is dy by dt into dt by dx. Reciprocal second. That is a t sin t into dx by dt is reciprocal equals 1 by a t cos t. That is a t and a t cuts, therefore sin t by cos t. dy by dx is defined as sin t. Next, d2y by dx squared equals d by dx of tan t, dy by dx, it's the second derivative, tan t, dy by dx of tan t equals c squared t dt by dx, that is t is the implicit. Therefore, d c squared t dt by dx. That is c squared t by dx by dt. Dx by dt is defined as at cos t here. Therefore, c squared t by, instead of dx by dt, at cos t. That is, cos t comes up as ct. Ct into c squared t gives c cubed t by at. At remains here. Why? Because cos t comes here as ct. Ct into c squared t, c cubed t by at, which is defined as d2y by dx squared. Subscribe Diamond Solutions for Mathematics for easy and tough questions of mathematics.